This is Year 13 AS1 Physics 1, and this is a series of past paper questions on forces from 2004 to 2009. So this is question 1, it's from June 2004, I'll just scan in a wee bit. To investigate the frictional force between the tyres of a four-wheeled car and a type of road surface, the car is placed on a test ramp covered with the road surface as shown in figure 2.1. And you can see that the car has been inclined at an angle here. The car wheels are locked to prevent them rotating, and the car is slowly raised until the car just slides down the ramp at a steady speed. The angle of the ramp when this occurs is 39 degrees. The mass of the car is 850 kilograms. Calculate the mean frictional force between the road surface and one of the car tyres. So we're going to have a wee look at the diagram first of all and see what's happening there. And therefore, if we have a wee look, obviously if the car isn't going to slide down the ramp, there has to be a frictional force acting up the slope. I'm just going to draw it from the middle of the car. But you also have the weight of the car acting straight down towards the centre of the earth. And you draw it like that. And you have a component of this weight which is acting against the frictional force, and that's what is trying to drag it down the slope. So if I just draw in the components of the weight, you always draw a right angle triangle, and the arrows on the right angle triangle should meet the resultant. So like that and like that. So if this car is stationary and it's just about to slide down, or it's just, it's not moving, then Newton's first law applies, and any downward components are equal to any upward components. So in other words, the frictional component here, if I label it FR, is equal to the downward component of the weight. So what is that downward component? Well, the weight is the mass times acceleration due to gravity, so 850 times 9.81 is a mass, is a weight, but we have to find its component in this direction, so this is also 39 degrees. And then this is our weight times the sine, because it's opposite the angle. So that's, I'm not going to write that out, but I'll write W, the sine of 39 degrees. And this is W here. So that's what we're going to do a calculation, and that frictional force is equal to that. So if I just write that in then, frictional force, I'll just call it FR, is equal to W sine of 39, and that's equal to 850 times 9.81 times the sine of 39. And that rounded up gives you 5350 newtons. Now, the question asks you about one of the car tyres, and it's very easy to get to just miss that wee bit. It is highlighted in black, so that's 4 tyres. That's the total force, and therefore for one tyre, it's that value divided by 4, and that gives you 1340 newtons. And that's your final answer. Next part says, state the direction of this frictional force when the car is on the ramp, and that is, of course, up the ramp. Or you could say parallel to the slope and up the ramp, or something like that.